Hi everyone, I'm Kate Johnson, the president of Microsoft US, and I couldn't be more excited to welcome you to day 2 of Hack the Classroom. Yesterday, we explored the basics of code and how it can really open up new possibilities, a whole world of possibilities and opportunities for your students. And during today's episode, we'll build on those concepts and show you how to go from block to text-based coding with a series of hands-on tutorial. Perfect for educators who are ready to take their students to the next level. But before we do that, I'd like to introduce a few very, very special guests, all of whom possess key insights on emerging technology, computer science education, and the value of having future-ready skills. So why don't we start with a quick round of introductions. Lorraine, let's start with you.
Hi everyone, I'm Lorraine Bardeen. I'm Vice President and CTO for our enterprise commercial business at Microsoft, and that includes, well, commercial businesses. It also includes all of our industries, so that manufacturing and retail and healthcare and automotive and all the work we do across those industries. And I just recently took this job after about 18 years in engineering at Microsoft.
Thanks, Kate. I work as Partner Engagements Manager for our Microsoft AI for Accessibility program. And I love that I get to nurture relationships with startups, researchers, nonprofits, and provide them with AI resources in order to scale the impact of people living with disabilities in this world.
And I am Reggie Sharif. I'm a Partner Development Director, and I work with software companies and state and local government. And what I help them do is build apps using Microsoft technologies in a really cool and amazing way.
So cool. 3 great leaders doing 3 very significant things at our company. Just a couple of seconds on my background. I started as an engineer by trade. I actually went to engineering school, landed in a very technical job, and said, holy cow, I don't think I want to be in a lab all day long. What else is out there for me? And I worked for a great company who quickly moved me into tech sales. I've done a world of different things in the technical sales arena, and even did a stint in management consulting after I got my MBA. I've built a whole career in the tech space doing all sorts of different things across the commercial life cycle. But each of you have kind of unique backgrounds. I'd love for you just to tell me what first sparked your interest in STEM. And Lorraine, let's again start with you.
Thanks, Kate. So in some ways, I have sort of the opposite path into STEM from what you shared with me, which is I actually started more on the math, finance, business side. I ended up at Microsoft almost by accident, and that's when I completely fell in love with engineering. I fell in love with computer science and sort of did the opposite way in, because I grew up actually in a house with frankly, no exposure to technology. It didn't even occur to me that that was a path that could be a path for me. We moved around a lot. We didn't have a consistent place to be. And we certainly did not have computers or technology in my house. And so Microsoft actually is my introduction to STEM. I started at Microsoft as a math person and ended up falling in love with computer science and was able to learn on the job, which is, I think, quite different.
That's super cool and actually pretty inspiring. It's never too late to learn the skills that can actually shape the future. Reggie, tell me about how you got interested in STEM.
Yeah, it's interesting, but as a kid, I've always had a love for technology, right? But more importantly, I got into STEM through gaming. So I was one of those kids from the age of 6 and 7 years old that played video games all day long until my parents were completely upset, ready to throw the joystick out the window. And it was really, really interesting and exciting and passionate for me. So I was not around engineers at the time, young black man raised in the inner city, but I never really got to see an engineer. So my uncle ended up becoming an engineer in the electrical world. And I asked him, I said, well, the people that do video games, what is that called? What job is that? And he said, that's called software engineer. And if you want to be a software engineer, you go to school for computer science. And that was it. I was hooked from there, went on to college and studied computer science. And here I am today, working for one of the best companies in the world, doing engineering cool stuff.
And Heather, what about you?
Well, Kate, I have to tell you that growing up in my home, we had a lot of tech, assistive tech, actually. There were all of these gadgets that just helped me and my parents and my family live our everyday lives. Both of my parents are deaf. And so I'm a child of deaf adults known as a CODA, and I started signing at 6 months old. But in our house, there would be a gadget attached to the lamp every time the doorbell rang to let my parents know that there was someone at the door. Or there was this big, bulky teletypewriter known as a TTY that my parents would use and have to type in one line at a time to communicate to people outside of our homes. And so for me, I went to school majoring in electrical engineering, knowing that I wanted to help people like my parents. I knew that technology was a game changer, and I can't even tell you how it has just changed our families' lives, but other people living with disabilities too. So after school, I went and worked at a mobile manufacturing company for mobile devices. And so my career has pretty much started in mobile accessibility and moved on to web and now AI accessibility at Microsoft. So I really love the career journey I've been on.
Wow, Heather, that is truly inspirational. I love this notion of being surrounded by technology as a kid and then going to school, developing critical thinking skills and engineering, adding computer science to that. Tell me more examples of how you use comp sci and critical thinking in your everyday life at work or at home.
Having all of these different gadgets that helped us live our normal lives just really helped me think in terms of, wow, I wonder how technology interacts with each other. And so going to school, majoring in electrical engineering, I really became this systems thinking girl. I love thinking about how technology interacts with each other. And so that kind of led me down this path of just the mobile phone and what a game changer it has been and how it connects people with each other.
That is so cool. Lorraine, how about you? Critical thinking as a core skill every day in our workplace for sure. Add a little comp sci. What do you come up with either at work or at home?
Yeah, so I've been thinking about this a lot lately, actually, because for the past decade and a half, I was building products and sending them to customers. And now I'm focused on helping other companies do their whole digital transformation process. And so I've been thinking about what is it that software really does? Like, what is the story? What is the meaningful story? And I've decided that if you're familiar with Carol Dweck's work on growth mindset, it's something that I'm sure most educators have a lot of experience in. I think software is like the growth mindset for the real world. It's we as humans need to have our own growth mindset, but what software enables is that you can potentially improve anything if you really think about it cleverly, like Heather and her parents did. You can make something adaptive to anyone's need. You can think about, hey, well, this is a process that people have been using for a long time. How could we digitally make it more accessible to everyone? How could we make it more delightful to everyone? Like Reggie's examples with gaming. How can we bring joy to people more quickly and easily? And so to answer your question, to me, the mashup of critical thinking and software, it's really about thinking of software as a growth and empowerment opportunity for every single thing you encounter in the real world. And as long as you keep humans first and foremost and central to that, you can do so in an incredibly positive way.
Super cool. So, Reggie, you have experience working with Azure, AI, mixed reality, and so many cutting-edge technologies. Looking ahead, what problems of today do you think students will be able to solve with technology tomorrow?
That's an amazing question, and I'll just share a story, at least for the work that I get to do. So as you mentioned, I get to work and help software companies and state and local government. So every one of these software companies is trying to find ways for citizens to be able to interact better with government and or to develop solutions that make the state and local government teams' life easier, from a court system all the way to you name it, to licensing and permitting solutions. So I have the ability, one, to help these state and local governments with solutions in regards to, let's just take the most important thing right now, the pandemic. So I get to work with software companies that are developing solutions today to help with the pandemic. For example, one of the partners that I get to work with, they developed a mobile application and a mobile solution to allow citizens like you and I to do everything from schedule your COVID appointment to all the way down to getting your testing done and to getting your results all through your mobile phone. So when I think of the future generations that we have to come and the technology that'll be available, it will be another technology set that we use to help our partners that are developing solutions for police departments. So everything from transparency and policing through body camera and the video technologies that are out there that exist to solving problems like that to change real world solutions. So I see the next generation being able to take these technologies to help solve pandemics and to help solve unity and injustice through using and leveraging our cloud technologies to do it.
Well, I got to tell you, you three are pretty darn inspiring, and you embody the qualities of effective leaders, critical thinkers, and problem solvers. And I couldn't be prouder to call you my coworkers. Thank you so much for helping me emphasize the value of building future-ready skills. And I've enjoyed our time together, and I know your insights are going to make a big difference to this educator community. Thanks for everything. Have a great day, everybody. See you soon.
Thank you, everyone.
Have a great day.
Hello everybody, my name is Andrew Bowser. I'm a STEM leader for the Department of Education, and I'm here to support teachers and educators with success strategies for digital experiences. My role really is to run through this tutorial for you today and help you plan an event for Hour of Code. We have a fantastic little lesson here for you, and I can't wait to share this experience. This year, Minecraft Hour of Code is about equity and inclusion, and I'm going to demo a small sample of this amazing world. Let's get started. As you can see in this demo activity that I'm demonstrating right now, we're in a cute little quaint village, and I have a quest right here that I could go up and begin. One of the advantages of using coding in Minecraft Education Edition is that it's a product that students are completely familiar with. Now, they've done some great things here with this Minecraft Education Edition lesson. Now, if I walk up to our fisherman, I could right click and it's going to give me a great narrative that explains the quest. And the greatest thing about these activities is that they have some fantastic little innovations. Now you can see, for example, I have the ability to accept or reject this quest. And what I have to do right here is help the fisherman build a fishing dock. Now you can see here it says, "Hi friend, fishing is something we've never been good at, and the illagers from the next town over offered to help us learn how. But they recommend we build a dock first. Can you help us build a dock at the edge of the shore? We'll just need an outline. See if you could build it 6 blocks long and 4 blocks wide." Now again, if I was a student and I wanted to kind of promote my own independent learning, I can accept this quest, or I can reject this quest and go wander off and get a good idea on my spatial surroundings. But for this demo, we're going to accept this quest and we're going to teach you how to do some very simple Python coding. And some of the great aspects of Minecraft is that it does incorporate different KLAs. So you can see that I have to build a dock 6 blocks long, 4 blocks wide. So we're already incorporating some forms of numeracy in there. So now that I've got my quest, it's basically prompting me to press C to code. So I'm going to walk up to our lovely little cove where they would like to build a dock. And this is so immersive and so engaging. So you can see the pond and the water, you can see the cliffs. It creates this great form of engagement that you just don't find in any other activities. So let's begin our Python coding journey. I'm going to press C on my keyboard, and that brings up a lovely little coding agent. Now, one of the main reasons why I love to use this as an educator is because the learning is so tailored and so scaffolded. I can see there I have all of the instructions on how to use Python to build a dock, but I'm going to walk you through this particular process. So come with my Python coding journey with me and we'll get started. Okay, so here we are. We've got plenty of instructions and plenty of tutorials if you want to get the students to do some independent coding. But I'm going to walk you through this process. Now, Python is a very versatile form of coding. It's a very easy way of coding. The Minecraft Education Edition engine uses a modified form of Python coding, which makes it really easy for beginner teachers and students to start their journey. Now, You can see here we have to start our coding in Python to build a doc. Now, what I'm going to do is start by creating a for loop. So I'm going to have my agent build the doc for us by running some very fun and engaging snippets of code. So we're going to start using this lovely little Python notebook down the bottom here and start building our very first doc. So I'm going to follow the tutorial that you can see in the example code on the screen. And I'm going to write for I in range, and then I'm going to put basically how many times I want this for loop to repeat. So ideally, this will run the code how many times I put the integer in there. So in this regard, I'd want to run this loop 6 times because we want our doc to be 6 blocks long, okay? So I'm going to put a 6 in there. Now, when I hit enter, you'll notice that it creates a little indentation under my for loop. This basically explains that this is included within the loop. If I press backspace, I can go away from the indentation, but I want to make sure that it repeats whatever I put in this for loop. So let's write for agent.move forward. So that's going to move the agent forward for 6 times in my example right here because I'll put the integer 6, okay? And as it moves forward, I want it to get some planks every time it runs this cycle of code. So I'm going to write agent.give, and let's put the word planks in there. And I'm going to put comma. Now, the next 2 integers in my code will explain how many planks the agent gets. So I'm just going to put 2, following the example. And the next integer will explain at what slot in your inventory will the planks be placed in. Now I'm going to put 1. So I will get 2 planks and it will be placed in the first inventory slot. The last part of my code for this particular loop, I'm going to have the agent place the planks down from the inventory slot 1, because that's where we put our planks in the line just before that, in the first inventory slot. And I'm going to make sure it places it down. Now, the greatest thing about Minecraft Education Edition is that you can test your code and then reset the world so you can scaffold the learning. I'm a visual learner, so I like to break my problems up into bite-sized pieces. So now that I've written the very first part of code, let's test and see if the code works. Now, I'm going to hit the run button and we're going to watch our little agent execute this part of code 6 times. Now, while that's running, you can see my little agent is doing that absolutely flawlessly. Now that works fantastic and it looks great, but I've only built one side of our doc. And if I were to count each block, I can see that it's placed 6 blocks in a forward motion. Now, let's say that we want to expand our knowledge of coding and we want to build the next side of our lovely doc. I'm going to simply press C on my keyboard, and instead of resetting my entire code and starting again, I actually have the ability to reset my world. So I'm going to reset the world. That's going to take us back to the start of the coding activity, yet I can still keep the code that I've already written. So let's expand our code and do the end side of the doc. So I'm going to hit enter. Now, I don't want this to be in a loop. Otherwise, the agent is going to turn to the right every time it executes that form of code. So to get out of the loop, I'm going to hit backspace and we're going to write another lovely little bit of code. We're going to write agent.turn. So we want the agent to turn when it gets to the end of the doc to face a new direction so we can lay the other foundations of our doc. So I'm going to hit brackets and let's turn to the right. Okay, now that will allow our agent to turn to the right, and then we have to place another row of blocks. Now we want it 6 blocks long by 4 blocks wide. So by the time the agent gets to the end of the doc, he only has to turn right and then move forward 3 more times to make 4. So let's copy our code from the start for I in range, and let's move 3 more times forward. Now, the rest of the code is going to be very simple because we want it to do the same thing that it did when it was moving forward 6 times. So I'm simply going to copy this line of code and I'm going to paste it under our lovely new line of 3 blocks wide. So let's run this code and see if we are on the right track. So the greatest thing about this is that you can break this up and scaffold the learning. So you can see there, everything is going remarkably well to plan, and we're almost there with our example. What we need to do now is turn the agent to the right again and bring the blocks back to the starting point. So just like when we were starting our lovely form of code, we're going to bring the blocks, 6 blocks back towards the starting point. As you can see, it never has been easier to get students and educators into Python coding. So let's write that last bit of code. So I'm going to break our lovely little loop, and we're going to write one more loop in the end there to bring the code back to the start. So I'm going to copy the very first form of code for I in range, 6, and we want it to come back to the length that it went at. So that's going to be 6 blocks again. So let's copy that. Let's paste that. Now, we could write this code out in its entirety, but I find that once you kind of understand the journey and the process of coding, it's great to use those little shortcuts and really get acquainted with how to use Python and finish building your doc. Now, once I hit go, I'm going to show you how I've broken my Python coding on building a doc into 3 simple steps by using this lovely for loop. So we've got our lovely little agent moving forward 6 blocks. We've got our agent turning to the right and then moving forward 3 blocks. And then we've got our agent turning to the right and then moving back 6 blocks. So let's make sure that our agent does turn to the right before we come home. So let's write agent dot turn and then write the word right. Now, according to that code, our agent should move forward, turn right, move 3 blocks, turn right, move back to the 6 blocks. Let's see if it works. So I'm going to reset my world and we're going to run our code in its entirety. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Ta-da! We've finished our quest. This is one of the beauties of Minecraft Education Edition, especially using Python for coding events like the one that I've just described to you. Not only does it promote amazing spatial awareness, but the activities are so engaging. And you can see now that we've made our very first doc and we've coded it without even building our blocks ourselves. That's all the time that we have for today. I hope you've learned something new to take back to your students. Make sure you check out the Microsoft Educator Center for the full Minecraft lesson and stay right where you are for more resources, planning tips, and educator stories. Bye-bye.
Hola a todos, mi nombre es José Ángel y esto es MM Academy. Somos una pequeña academia tecnológica de Alcantarilla, un pequeño pueblo de la región de Murcia en España. Y aquí enseñamos a niños y niñas pues a programar, a crear videojuegos, a hacer robots, un montón de cosas que tienen que ver con la tecnología. Para nosotros Academy Code ha significado una herramienta imprescindible. Es una manera de introducir a los más pequeños desde bien jóvenes en lo que es la programación. Quiero felicitar a la organización de Academy Code por la última Game Jam. Sí que es cierto que nosotros nos apuntamos a todas las Game Jam y a los chicos y chicas les encanta, les supone una motivación extra, les gusta mucho y luego adoran cuando ven sus juegos publicados y sobre todo vosotros los comentáis. Una Game Jam es como un hackathon en el que los participantes tienen un tiempo límite para desarrollar un videojuego. Esta en concreto era la Traffic Jam, donde el tema elegido para los videojuegos tenía que ser algo relacionado con el tráfico. Nos ha encantado, nos ha gustado muchísimo, pero yo creo que mejor es que os expliquen nuestros alumnos cuáles han sido sus juegos.
Hola, soy Miguel. Este es mi juego, se llama Crazy Taxi. Aquí están las instrucciones al inicio, como se con las flechas, si vas por el centro vas más lento y tienes que recoger los clips. Luego, tú tienes que ir por la carretera buscando a la gente, por este tile map. Esta es la programación. Al iniciar tenemos la imagen que aparece al inicio explicándote las rectas. Luego te aparecen los textos de las instrucciones. Luego aparece otra imagen diciéndote lo que tienes que hacer y así es el inicio. Luego aparece un timer así un poco grande con esto. Luego tenemos el sprite de tipo jugador, que es un taxi. Luego mover al sprite con los botones y que la cámara siga al sprite, el taxi. Luego estos son los pasajeros. Aquí están los colisionadores. Cuando un sprite de tipo jugador toca a otro de tipo comida 2, se coloca en un lugar random de este bloque de timer y la cuenta se reinicia. Lo mismo pasa aquí, pero en otra zona. Luego, lo que más me ha costado es el timer, porque tuve que coger todos los bloques de aquí e ir construyendo poco a poco. Y luego yo creo mis propios bloques que están aquí para poder crear el easter egg. El easter egg está escondido por unas murallas, excepto uno que está al lado de este cruce. Entonces tú aquí al entrar encontrarás el easter egg de Mario. Mi parte favorita han sido las animaciones. Por ejemplo, he hecho una para bajar, otra para la derecha, otra para la izquierda, no para abajo, una para cuando presiones el botón A, y otra para cuando vas a la izquierda. Me encantan los videojuegos y me encanta Academy Com.
Hola, me llamo Lucía, tengo 10 años y me encanta programar. Este es mi juego, se llama The Card y es así. Aquí está el inicio que explica cómo jugar. Y este es el juego. Tienes que ir cuidado de no chocarte con las piedras y no quedarte sin gasolina cogiendo estas latas. También aquí atrás tenemos un easter egg que si te metes te conviertes en este personaje. Ahora os voy a enseñar la programación. Tenemos las pantallas de inicio, los textos. Aquí tenemos el sprite de la carretera, el del easter egg y el principal, que es el coche. Y aquí está el de la barra de gasolina. Este es el colisionador del enemigo, que son las piedras. Este es qué pasa cuando te chocas con una piedra, que te resta una vida. Este es el de las latas de gasolina. Aquí arriba tenemos la animación de la carretera y el personaje del easter egg. Lo que más me gusta hacer ha sido el easter egg. El easter egg está aquí escondido detrás de los corazones. ¿Veis? Me meto y sale. Lo que más me gustó hacer fue la animación de la carretera, porque para simular que nos estábamos moviendo hicimos el sprite y aquí lo animamos. I love Mexico.
Hola, soy Dylan y tengo 10 años y aquí tengo mi juego que se llama Corre, Coche, Corre. Pues aquí está la gasolina, que tenemos que coger gasolina o si no pierdes. Aquí están las piedras, porque si te chocas pierdes una vida. Pues esta es mi programación. Aquí está el fondo de pantalla que yo hice. Y aquí están los sprites que yo he hecho. Este es la carretera, este es el sprite que tienes que usar para conducirlo y este es un easter egg. Y está muy escondido. Pues este es el enemigo que sale a cada rato. Este es el easter egg que yo hice de Naruto. Pues lo más que me costó fue la gasolina, que teníamos que poner todo esto. Lo más que me gustó fue que Jacqueline jugó a mi juego de la tacita.
Greetings, my name is Steve Dembo and I'm the Computer Science and Artificial Intelligence teacher at Quest Academy in Palatine. I teach middle school, 5th through 8th grade, and I've been using Microsoft Make Code for a number of years. We've used it for Lego EV3, we used it extensively for Microbit, and when they added the arcade version, I was very, very excited because obviously students are, into video games. It's sort of a natural inspiration to them, a natural way to tie in their personal interests. And I did it initially with 5th grade, but I have found that it really what served as a great introduction to more complex coding concepts for our 8th graders. We just wrapped up a lesson where they were supposed to create a tile map or maze-style game around a core curricular topic outside of computer science. So the students were able to pick a favorite project or a favorite lesson that they did in one of their other classes, and they were supposed to bring it to life through code. The nice thing about this is I've always tried to instill in our students the idea that coding is a way to express yourself. It's not just about ones and zeros, bits and bytes. When it's done right, it should be almost like singing a song or painting a picture or writing a story. When it's done right, it should be a way for you to take something that you are thinking or feeling or some information that you want to communicate and giving you new avenues for sharing it out, new ways to synthesize it, to remix it, and to put it out there for the world. So we created these stories. This is one that was done by one of our students, Chen, and she decided to take on the subject of Spanish, where one of the things that Miss Kropp has, Senora Kropp has, is mascots for every class. And so what she did was she took this mascot from Spanish and made it come alive in a very creative way. There's either an endless version of this game or a story version of this game. If you go into the story, you can see these bright, beautiful graphics that she included into there, and the story itself is entirely in Spanish. If you don't know Spanish, well, this might be a little bit of a challenge for you, but once you get into the game, it'll be fine. She even included a little Easter egg, and it was a way to skip the introduction if you want to. But as you can see, it's multiple screens. It's very almost poetic in a sense, and it's telling this entire story that tees up the game itself. It's a lot of fun. And this is what I want. I don't want it to just be something sterile. I don't want it to just be a character chasing, picking up coins and chasing a princess or something like that. It should be something that's individual, something that's personal. It should be a form of self-expression. And then you can kind of see here you're still playing the cat and you're working on trying to pick up all these different things. This was a little bit lighter, but then we've got things like this one. We had several students try and take on math. This was Tuana's, and she did something called the Big Book of Math, where you start off reading this big book, and unfortunately you wind up getting sucked into it. You can see the story getting set up in through these different splash screens, and then once you get sucked into the book, there are actually multiple levels, multiple tile maps, and so on. Now, what I love about this is not only is she working very, very hard to work the theme of math or come up with a creative way to work the theme of math into this game, but what she's also doing is stretching her ideas of what she's capable of. What I look for in a coding platform is something that has a very low floor and a very high ceiling. Something where it's very accessible to students, that they can get in and be successful in a very short time, but where they're going to have a very hard time maxing it out. They're not going to be able to just hit a ceiling. I want students to always be building on the knowledge that they already had. So whatever they did previously to this, we want to start there and then start adding even more layers, which is why we focus so much on planning out these games. And when they plan it out, we don't restrict it simply to the things that they know how to do. I want them to dream big. I want them to say, well, what could this look like? How could this function? How would this theme actually enact itself in video game form? Even if they don't know how to do that yet, and then use the immense tools at hand in Microsoft Make Code to try and bring that to life. A good example of that, and beyond this one, was Ant's dungeon quest, where you play as a circle, and you are going up against other geometric shapes. So as you battle these other geometric shapes, you do so by fighting them, hitting them with your things, and depending on how many sides they have, every time they take damage, the number of sides goes down by 1. Even better, there's actual ways to do level ups. You may have noticed that this main player is running a little slowly at first. Well, with enough level ups, if you actually find chests and get coins and things like that, you can actually buy level up so that you can move faster, you'll be stronger, you'll be able to survive more hits. But if you notice, it went from the square to the triangle and so on. The pentagon is a very, very difficult enemy, to say the least. So just what a creative way to take the idea of geometry and work it into a video game concept. And that's what we want. That's what we want. We want, when they're doing a history project, for them to think of code as a way for them to demonstrate their knowledge and understanding of what they've learned in history. Speaking of history, this is one that was done by one of my students named Brad. And what you can see here is the blog posts that went along with his project. I believe that it's important for everyone, when they finish a project, to step back and think, what went well? What didn't go well? What was a challenge for me? How did I overcome that challenge? To celebrate their successes and to consider the things that didn't go well, what they might do differently next time. So every time they finish a project, we post it up on the blog, and they add a reflection to that where they identify the things that they're most proud of and also the things that they're going to be working on for the next time. This is the game that Grad made, where you play as an American operative in Russia in 1944 in the middle of the Cold War, and you are trying to capture intel that has been scattered in capsules around the map. Now, of course, if you thought it was going to be so simple as to just simply run over those capsules, well, you've got another thing coming. He decided that he wanted to work in the idea of ciphers into his game. And so all of the codes are going to be encrypted. Let me just go ahead and type in my name right here. So, your goal is simple, scattered throughout the town is this intel. There's one catch though, all of the codes are encrypted. And the ciphers that he used for the encryption are real ciphers. They're real ciphers that they were using during that time. Caesar ciphers, where shifts the values by a certain amount. An A1Z26 cipher, and he teaches you what these ciphers are at the beginning, and then as you play the game, you need to make use of that knowledge and actually decrypt the codes as you go along. Now, not only was this game incredibly creative, not only is the map that he created incredibly detailed, but he talks about in his blog post how one thing that he really wanted was a way for the character to go underground, to go through tunnels, and he couldn't figure out any way to do it. And then he realized, well, if at a certain point I just make the character hide, so the sprite is still there on the map, but we just don't see it, effectively, that makes it seem like he might be underground. So he added the maze, and he made these little tunnels so you can see the outline, and you can kind of get this sense of where the character is, and just this incredibly creative way to accomplish this stretch goal of his, this vision that he had of something that he'd like to do, but didn't necessarily have the skills to do it when he started. By dreaming big, that's when you have the opportunity to do something that you quite simply haven't done before. And that's one of the things that I want the students to do. Overall, I really put a big emphasis on the planning. I want them to stretch themselves, and I believe that if you simply start off and jump right into the code, more often than not, you will constrain yourselves to the things that you already know how to do. So I try to make sure that they set themselves up to take themselves out of their comfort zone. When one student says, I'm trying to figure out how to make an A, B, or C multiple choice question, then we put together a little demo and we all talk about that. And by doing that, by waiting for those teachable moments, the lessons are a little bit more organic and less arbitrary. I'm not introducing concepts before they're ready to learn it. I'm introducing concepts that they need at that exact moment. And the next thing is I want them, when I'm looking at their code, I want them to be effective coders. A lot of times, because they default to the way they've always done it, it might not be the most effective way to do it. So a lot of times when I'm showing them an idea how to do dialogue boxes or something like that, I'll show them 3 different ways to do the exact same thing so they can determine what is going to be the most effective one for the project that they have going on at that time. I want them to understand that there are multiple ways to do the same thing. I want them to always keep the player in mind, the person who's going to be sitting down there that may not know what's in their head. They weren't the ones who created it. They don't know where everything is hidden. That they should always be kind to the player and give them incentive to want to keep playing. And it's not just for games, it's for all code. We want user interfaces that are inviting and friendly and allow people to actually make use of the things that we create. And the last thing is I want these things to be personalized. Whenever somebody tells me I wasn't into this project, it's soul crushing to me because there's so many ways that they can demonstrate their knowledge, so many ways that they can learn these new skills. In my opinion, it should always be something that they're going to be passionate about, that they're going to be excited about, that they're going to want to work on, that they're going, the way I look at it is, if I'm doing things right, when we're done, they say, Mr. Demo, can we keep doing? Can we keep working on it? And that's what my goal is. There's a whole lot of other projects that I could show you that unfortunately I haven't had a chance to work in. Things like this one where Sophia was writing about Asian American propaganda, where the negative propaganda hurts the character, and if they can avoid these negative stories, that's how they escape through America in the mid-1900s and so on. And games like this one, which is one of the more creative ideas I've seen out of any student, when I asked them what topic would you like to take on, what subject area would you like to take on, Carolyn said she'd like to take on the map standardized test. And so she created a game where you actually have to go through the map standards, which looks just like it. There's a session name, there's a password, and so on. And after you enter those things in, then you can actually start to play the game. So we do that password. I can't believe the map test is starting. What is happening? You get sucked into the test and you have to try and escape it. And as you're trying to escape it, you're getting bombarded by questions. One of the things that I love that she did in this was instead of just having one question, she has 6 different questions for each, and it chooses which one randomly, which means that if you just play the game, there are dozens of questions that you don't even get to, which encourages repeat play. Just kind of a great idea. You know what I mean? We want kids to make their games a little bit more engaging. We don't want them to make it repetitive. So the idea of working those kinds of things in is just a lot of fun. And anyone that could turn a standardized test, one of the most boring things in the entire world, into a game, well, that's exactly the type of creativity we're looking for. Our next step is taking these arcade games that the students have worked so hard on and building physical structures so the other students in the school can play them. We're actually going to be starting this week on distributing Raspberry Pis to each of the students and sets of arcade buttons and wires and all the rest. And they are actually going to be wiring up the Raspberry Pi, transferring their games over to it, and creating a structure so that other people can play their games physically and not just in the web browser. End to end. That's what we're looking for. It gives us this bridge from coding, very sophisticated block coding, to physical computing. And when we're ready to make the switch into Python or JavaScript, we have that option as well. It's been a great, great project to do with the students, a great way for us to really kick off coding at a deep, immersive level, and I'm looking forward to seeing where their next project takes them. So thank you for joining me today. Thank you for letting me share the great work that is being done by the 8th graders at Quest Academy in Palatine. And if you have any questions or you want to hear more about what these amazing students are doing, please don't hesitate to let me know. Signing off. Thank you. Have a great day.
What's up, y'all? It's Fees here, and I want to talk about gaming as something more than just a thing done for fun. Over the years, since I was a little kid, I've played a variety of games, and many of them were actually educational games. Like, I remember being a kid playing Math Blaster, for example, and having to solve math problems super quickly to launch a missile at an asteroid or something like that. I remember playing games like Mario Typing Tutor, which actually improved my typing significantly. I probably wouldn't have practiced as much if it weren't for the fact that you had Mario running across the screen and jumping. Thought that was cool. And then Carmen Sandiego, which many people don't remember or know, but I had a blast playing that game, and it taught me a number of things, from geography to just history. You know, because you'd go around the world, specifically in Where in the World is Carmen Sandiego, you'd go around the world and you'd ask people questions and they'd give you hints. But to know where the criminal went, you had to actually be familiar with a variety of things. And I think that while people look at gaming as something that's just used for fun, which it is also used for, I think that there are many educational benefits to it. And that's part of the reason why I came to Minecraft, and I'm working on Minecraft Education Edition, because I'm very passionate about education. And I saw it as a great tool to use to teach students, especially, you know, since my young cousins are actually already using it in school, and they've been using it to learn how to code for years. And especially in a game like Minecraft, where you can kind of build what you want. To be honest, you know, there are games where you're playing a story, you know, there's a narrative that's already created, and you're just playing through that game. And even those games you can still learn from, but a game like Minecraft, you have the opportunity to create your own narrative. And I think that is very powerful, and it's something that should be embraced and something that we should be promoting, because, you know, there are a variety of ways to teach. And you can teach students, you know, where they're passively learning, you know, there's somebody speaking to them and they're just sitting there and listening. And then there are ways that they can actively be learning. And when you have something as interactive as Minecraft, the students are engaged, and I believe that they actually retain the information much better than they would if somebody was just speaking to them. So I think that we should continue to use games like Minecraft and whatever other, you know, educational games are out there to teach students and get them excited about education. Because I honestly wouldn't be where I am today if it weren't for the fact that I saw games as more than just something that I did when I was bored, as entertainment. You know, I thought about them differently. You know, when I was playing Crash Bandicoot and, you know, he was, you know, running and jumping over some hole or some enemy in the game, I wasn't just thinking, you know, okay, I ran and I jumped, right? I was thinking, oh wow, I wonder what type of math was used, you know, to model the correct physics equation to get Crash over that hole. You know, you can call me, you know, maybe that's just me, but I don't think I'm the only one, and I think we should continue to use games to inspire the next generation of software engineers.
Hello everyone, my name is Maria and I am from Minecraft Education Team. I'm here today to show you materials that we talked about earlier. All the materials are free and available to educators or parents if you're ready to facilitate Hour of Code 2020. Let's get started. As we're going along with the materials, if you have any questions, drop them in the chat or have them on Twitter with our Twitter handle @MicrosoftEDU. So let's look at the materials that we have for Hour of Code. And down there, you have a great selection of materials that are available for successful facilitation of Hour of Code with Minecraft. Also, we have other resources that are available for you that you want to progress from the Hour of Code into the computer science subject kit page. Let's go ahead and have a look at the materials. You can see that you can access the video from here and all the free resources that our educators were talking about earlier. You can download the Minecraft Education Edition from here, you can get the lesson plan, and you can actually get a guide on how to facilitate the Hour of Code. Now, let's have a look at step 4 for more computer science resources. So as we're talking about other computer science resources for Minecraft Education Edition, we have a journey on the website that you can see that consists of beginner, intermediate, and advanced materials. So today, we will definitely recommend you jump into intermediate or advanced section of materials. There are several curriculum that handle this users, for example, coding with Minecraft, or any of the Python courses. If you want to get to the actual materials, you just need to scroll down and you will see the intermediate lessons right there on the page, followed by Python courses and advanced lessons. Going back to the resource pack for Hour of Code, I wanted to talk to you about specific courses that you can take. These are either Minecraft Coding Academy or specifically Hour of Code facilitator training. So if you want to get training specifically in facilitation of Hour of Code, click on the Hour of Code facilitator training. If you want to have a training more specific towards the computer science education and how to facilitate lessons with Minecraft in coding, go and open up Coding Academy. All these resources, as I said, are free and available to you. One more great resource that you can use for Hour of Code 2020 is MakeCode resources or MakeCode Hour of Code resources. On this page, on the same page, you can find specific activities for the Hour of Code that I can demonstrate right now. So for the Hour of Code 2020, MakeCode Arcade created 3 play, design, and code activities that can be accessed online. And now, after completing these activities, you can get your certificate and print it out. If we go back to our Hack the Classroom page, there are some more additional resources for educators and parents that include MakeCode Arcade curriculum and access to some other additional resources for educators and parents. Also, there is some information on connecting MakeCode to GitHub for student collaboration. As I showed you previously, there are awesome materials for all of you that are available for free for facilitation of Hour of Code 2020. We wish you really successful Hour of Code 2020 and thank you for being with us today. Have a great day.
Hi everyone, it's Heather again. I'm honored to be here to close out day 2 of Hack the Classroom. I enjoyed our roundtable discussion so much that I had to come back. I hope you were able to take away some coding tips that you can apply in the coming days during Hour of Code. But I also hope today opened your eyes to some bigger lessons coding can teach us. Coding also requires soft skills like observation, emotional intelligence, and critical thinking. The ability to connect dots. I love connecting dots, and I do so every day in my work at Microsoft. Coding can be a pathway to change, a way to break down barriers, especially for people living with disabilities. There are more than 1 billion people on this planet living with disabilities. We need students who are mindful about the world around them and the impact they can have. We need future engineers, programmers, and problem solvers who can approach challenges differently, who see things in different ways, who see everyone, and use their creativity to build solutions that will disrupt the way we've always done things. That's why I'm in AI for accessibility, to disrupt the status quo for people living with disabilities. No one knows this better than you. There are students in your class right now who have the ability to create these bridges that make everyday life more inclusive, accessible, and honestly, way cooler. I also hope you were able to tell by the diverse backgrounds of everyone you met today how many doors coding can open, doors you might least expect. Once your students have that key, the possibilities truly are endless. Are you as excited as I am to think about those possibilities? That's exactly why you should join us tomorrow, when Microsoft will be back to show your students how to continue to take steps towards using technology and their coding skills for good. An exciting lineup of professional problem solvers will be here to talk about how they do it out in the real world. You don't want to miss it. Bye.